Next, I want to write an expression for, oops, this is example 4, for sine of, let's try that again. For sine of 40 cosine 135 minus cosine 40 sine 135 as the sine, cosine, or tangent of an angle. So really all you have to do is look at it and figure out which of these patterns it is. If it goes sine, cosine, cosine, sine, that is a sine. And then my A and my B, so 40 and 135. And if you remember on sine, whatever this sine is, this one is. So minus goes here. So this is equivalent to sine of negative 95. So now instead of me giving you this and making you go to this, I'm giving you this and asking you to tell me what it basically would condense to. Example 5, we're going to do the same thing we did on the last one. I have cosine pi over 16, cosine 3 pi over 16 minus sine of pi over 16, sine of 3 pi over 16. Again, we look and see this is cosine, cosine, sine, sine, which means it's cosine. This is my A, this is my B, pi over 16, 3 pi over 16. And on cosine, whatever sign this is, the one in here is opposite. So it's going to make this a plus instead of a minus. So that's cosine of 4 pi over 16, which is cosine of pi over 4, which we can figure out. So it said to find the exact value. So the cosine at pi over 4 is just square root of 2 over 2. Okay, number 6 says write cosine arc sine square root of 3 over 2 plus arc cosine x as an algebraic, it's supposed to say expression, of x that does not involve trigonometric functions. So we're going to kind of have to start from the inside out. Let me write it down. So this is cosine, and this is probably going to take a couple screens. Arc sine square root of 3 over 2 plus arc cosine x. I'm going to deal with this first. If you remember for arc sine has to be in one of these two quadrants. And since that's positive, that means we're in the first quadrant. And sine, then we have to figure out where sine is square root of 3 over 2 if it's on our unit circle. And if you look on your unit circle, sine is square root of 3 over 2. Let me go look. At pi over 3. So we're going to replace this, this whole thing, with pi over 3. So now we're down to cosine pi over 3 plus arc cosine x. So we've simplified some stuff if we can. So you're looking that up on there. So now in order to do this, I'm going to do this on the next screen. We're going to have to do, this is a sum, we're doing a sum and difference. So cosine, make this A. We're going to make this whole thing A. And we'll make this whole thing B. Okay? So you might want to pause it and copy this. I'm going to go on to the next screen. On the last screen, we ended with cosine of pi over 3 plus arc cosine x, which means I'm going to do cosine of A plus B. Let's do blue. So it's going to be cosine pi over 3, cosine of arc cosine, cosine, sine, sine. Okay, so you might want to pause and take a minute to copy all that down because we're going to have to do a little bit of work. So we'll deal with the cosine of pi over 3 and sine of pi over 3 later because that's on our unit circle. We're going to deal with this part right now. So remember when you combine your arc cosine and your cosines, I have to set up a triangle for the arc cosine part. And since this is cosine of x and x is positive, we're going to be setting it up in the first quadrant because you need that for this evaluation and for this one over here. So remember, cosine is adjacent over hypotenuse. So remember, you can always turn this into x over 1 adjacent over hypotenuse, which means if you do Pythagorean theorem, you're going to get square root of 1 minus x squared as that opposite side. So once you have the triangle drawn from the arc cosine, then I can evaluate cosine. Well, obviously, if you do cosine of arc cosine, you're going to go back and get cosine of this triangle as adjacent over hypotenuse. So for this one, your cosine of this triangle, so you use arc cosine, you set up the triangle, and then find cosine of that triangle. So cosine is x over 1, so it's just x. And then we can come back over here and do cosine of pi over 3, if you look on your unit circle, as a half. Except we need to make this minus, not plus. So let me fix that up here. That's a minus. And then sine at pi over 3 is square root of 3 over 2. And then arc cosine, these two insides are the same. So we're going to use the same triangle over here. But now the arc cosine thing is already set up here. But now instead of finding the cosine of the triangle, I need to find sine of the triangle, which is your opposite over your adjacent, your opposite over your hypotenuse. And so that is square root of 1 minus x squared over 1. And on the next screen, I'll simplify this. So pause it, take a minute, and copy it down. So on the last screen, we got to 1/2 times x minus square root of 3 over 2 times square root of 1 minus x squared over 1. So that simplifies to x over 2. The part on the right simplifies to, oh, wait a minute. No, we're fine. Simplifies to, hold on. I'll leave it on red. Okay. So that simplifies to square root of 3 minus 3x squared over 2. And then, again, just write it as 1. X minus square root of 3 minus 3x squared over 2. Okay, number 8. Oh, wait, I didn't do 7. Okay, 7. Okay, it says given sine A equals 5/13, where the domain of A is pi over 2 to pi. So sine of A equals 5/13, and that's pi over 2 to pi. And then cosine of B equals negative 3/5 pi to 3 pi over 2. They want you to find sine of A minus B and cosecant of A minus B. So the first thing you need to do is you need to set up your triangles. So I'm going to do this on this screen, and then I'm going to make it smaller on the next one. Actually, let me erase this. I'll make it purple. Okay, because you need to have A and B set up. So pi over 2 to pi means that the triangle is going to go in the second quadrant for A. And then sine is opposite over hypotenuse. And if you do Pythagorean theorem, you're going to get 12 for this side. And since you're going to the left, that's a negative 12. So you need to set up your triangles to answer the rest of your questions. So then on cosine of B, pi to 3 pi, oh, that's supposed to say 3 pi over 2. Pi to 3 pi over 2, that is in the third quadrant. And I'm going to put angle B here so we know which one is which. And cosine is adjacent over hypotenuse, which means if you do Pythagorean theorem, you're going to get negative 4 for this side. So you may want to pause it and copy it down before the next screen, because I'm going to go and draw this in again where I have more space. Okay, so now I'm just going to redraw real quick my triangles from the previous screen. This is 5, negative 12. This is triangle A. Triangle B, negative 3, negative 4, 5. So I want to find sine of A minus B. So that means I'm doing sine, cosine, cosine, sine, and sine's the same sign. So then we're just going to basically get each of these off of the triangles. So I want to find sine off of triangle A. So I look at triangle A, and I get my sine ratio. So my sine ratio is opposite over hypotenuse, so it's 5/13. Then I'm going to find cosine of the B triangle, which is negative 3 over 5 minus. Then I'm going to find cosine on the A triangle and sine on the B triangle. So all you're doing is basically setting it up and then just getting your information off of your triangles. So cosine off the A is negative 12 over 13. Sine off the B is negative 4 over 5. You should not have any of these fractions repeating. If you have any of them, except for if it's a 45-degree one, you have square root of 2 over 2's. But if these are two different things, you should not have the same one. So then we're just going to multiply. So 5 over 13 times negative 3 over 5 gives me negative 15 over 65. And then all of this stuff over here, a minus, and a minus, will give me a minus. 12 times 4 is 48 over 65. And when you put it together, you get negative 63 over 65. That is my sine. But then part B also said to find cosecant. So I'm going to kind of come up here because I don't need much space. And if you recall, cosecant is reciprocal sine. So all you really have to do is just find the sine ratio and flip it upside down. So that's negative 65 over 63. Okay, last problem. Find all the solutions to sine of x plus pi over 3 plus sine of x minus pi over 3 equals 1. So sine of x plus pi over 3 plus sine of x minus pi over 3 equals 1. So I'm going to expand this one out first. Again, a plus b, which is going to be sine, cosine, cosine, sine, and then I'll do the second one, but with a minus sign. Sine, cosine, cosine, sine, and that all equals 1, sorry. If I put these together, you may have noticed that these are going to cancel. So which is going to make this 2 sine cosine pi over 3 equals 1. Divide both sides by 2. Oops, sorry, I forgot the x. Sine cosine equals a half. And then cosine pi over 3, if you look it up on your unit circle, that is your 60 degrees, is a half. So I have sine of x times a half equals a half, which means if I multiply both sides by 2 to get rid of my 1/2, I get sine of x equals 1. And this one just said find all the solutions, so it didn't give you any restrictions. So the only place that sine is 1 is up here at pi over 2. And if I want to include it, since there's no restrictions, and I need to say that it's going to go on forever, I'm going to add 2n pi to the end. And that is the end of the video.